Hi there, this is Navneet and welcome to my channel Navneet Technical. In this video, we are going to see how to add two 8-bit hexadecimal numbers in 8086 programming. So without any delay, let's start. First of all, without actually going directly into programming, I just want to give an overview actually what is going to happen in this video. So here, we are going to add two 8-bit hexadecimal numbers, and in particular the numbers we are going to add in this video are BF and CD. One thing you have to remember is in order to add any two numbers in 8086, first of all we have to move the two numbers into any of the general purpose registers at a particular location. So as we are adding 8-bit numbers in this video, we can choose any of the 8-bit registers like AL, CL or BL. In this video, we are going to use AL. So this is the introduction, and coming to programming, the first step we have to do is we have to move BF into register AL at a memory location 3000. So actually we don't hard code this 3000 in our program. Instead we will make a SI point to that 3000 H. So now BF is moved to register AL at a memory location 3000 H that is pointed by SI. In the same way, we have to move this CD to the memory location 3001 H successive of 3000 H into the register BL. Actually, you can see over here we incremented SI. Why that increment in SI came into picture? In 8086, one memory location can accommodate 8-bit number. So we moved BF into AL register at memory location 3000 already. Now at 3000 location, BF is already present. That is 3000 is already filled with an 8-bit number. So how can it accommodate another 8-bit number? So that's why we increment SI. That is, we incremented memory location by 1, and in that memory location we move CD. So now two numbers are being moved and they are ready to add, and we have a mnemonic code add in order to add these two numbers. No problem with that. Now coming to result, when we add two 8-bit numbers, we can get either 8-bit or 9-bit based on the carry. If we get 8-bit number, there's no problem. Directly we can store it into AL or move it into AL, that is at memory location 3002H, and no problem at all. But what if carry occurs? So if carry occurs, that is if the result is of 9-bit, we move that carry to AH at memory location 3003. Remember, these memory locations are actually important, so understand it carefully. The first number is at memory location BF. Next we incremented SI by 1. Now SI is pointing to 3001 location, and we moved CD to that memory location 3001, and again we incremented SI because 3001 is already filled with CD. Now SI is pointing to 3002 location, and we stored the result, that is lower bit result, into 3002 location, and if carry occurred, that particular bit will be stored into AH. Okay, I think you got it. Now we will enter into program. So let me minimize this window and actually open dosbox. Yeah, before going to that, the numbers we are adding are BF and CD. So let's see what will be the result first of all, so that we can figure out whether our program is working perfectly or not. So for that, I'll just open calculator in my laptop. Just type in calculator. Now we have to add hexadecimal numbers actually. So click over here options and click on this programmer. Now we can use hexadecimal number calculator. Now just type in your keyboard BF plus CD. See, the result is 18C, that is the lower 8-bit result is 8C, and a carry occurred over here, that is 1. So remember this result so that we can figure out our program is working perfectly or not. Now let us open dosbox. So we saw in the previous video, so do the same steps, mount d space d colon backslash and 8086 and click enter, navigate to d. Okay. Now just type edit. Now let's start our programming. The first step in any of the program is these 3 lines will be common actually. So code CG code segment and assume CS code and strt start. Our code starts from here. So what is the first step? Actually we have to point that SI to memory location 3000. So move SI comma 3000H. Now we have to move the number BF to this memory location in the register AL. So type the command move AL comma location SI. So with this command we moved the number BF into the register AL at memory location 3000. Now 3000 memory location is already filled with AL. So what we have to do? We have to increment SI in order to store another number, that is in the register BL in our case. So just type in move BL comma memory location SI. Now 2 numbers are being loaded, just we have to add them. So type to add, that is add AL comma BL. Now we have been added, that is we have added the 2 numbers. So we have to move that result to some memory location. Now BL, that is BL is already stored in 3001. So what we have to do? We have to again increment SI and move the content of SI to AL. That's it. Now our lower 8-bit result is there in memory location SI. So what if carry occurs? So we are going to use is JC, that is jump if carry occurs, to where? To location L1. So in our case, if carry occurs, this JC L1, I mean this line will take to the location L1. So we have to specify location L1 somewhere in our program. So we will specify that L1 over here. So what we have to do if carry occurs? Now the result is already ready at a memory location SI. That is, it is already 8-bit is already filled in that. So in order to move another 8-bit or maybe any one of the bit, we have to increment SI, right? So increment SI and now move where we have to, where we have stored that carry. We have seen in the previous, just a few minutes ago, we have stored that carry in AH, right? So move content of SI comma AH. So that's it. Just type in int 3, and this int 3 is nothing but just in order to stop the program, and after these int 3 no commands will be executed. Now we specified if carry occurs, but what if carry does not occur? We have to just store a 00 as is and just move on. So just type in increment SI and move memory location SI comma AH and just type in int 3. And at last our program is ready. Now at last we have to type code end s and end strt start in order to end the program. Now let us see once again. Actually we have used ah over here, but we did not declare actually. So first of all, use that ah over here, move ah comma 0 0 0 h. That's it. Now let us see once our program. So as we are using ah over here, so just in order to initialize it, we are moving 0 0 0 h to al, and the next step we are doing over here is we are making si to point to 3000 location. The next step is move al comma box of si is we are moving the content of al to memory location 3000h. Now we are incrementing si, that is memory location 3000 is already filled with al, so in order to move another number we are incrementing si. Now in the next step, add al comma bl, we are adding these two numbers, and we are again incrementing si. You know that why we are incrementing. Now we are moving the lower 8-bit result to al, and now we are specifying over here jump carry l1. So here we add an instruction add al comma bl. So if carry occurs in this particular instruction, this l1 will be executed. So what we are doing in l1, we are again incrementing si to store carry in ah, so into 3, and if carry does not occur, we are moving the same 0 0 0 0 h into the ah. Now we have to save this program. So just go over here, file. So you can see this golden color cursor. So just take it to file and click on this save as. So we have to name our program over here. So what we name is 8-bit dot asm. See, the extension should be .asm. The name, it doesn't matter, but the extension should be asm. So click on OK over here. Just remember this name, 8bi and triple t. So just click OK. Now we have saved our program. Now we have to execute it. So just file and exit. So just type in masm. What is our program name? 8bi triple t dot asm. Now just click enter 4 times. 1 2 3 4. See, there are no errors in our program. Now the next step is we have to link that object file, that is type in link our program name 8-bit dot obj. Now again 4 times enter. Now in order to debug our program, just type in debug our program name 8-bit dot exe. Now we have entered into debug. Now let's run our program first. So in order to run our program, just type in g equal to 4 zeros. Now we ran our program. Now we have to give values to the program. That is, we specified that take al from location 3000 and bl from location 3001. So we have to give that inputs, right, at 3000 and 3001 location. So to give inputs, just type in e and 3000, the starting location. Just type in enter. Now here we have to give the value of al, that is 3000 location. Now we already have, we can see over there b8 over there. So the old value over 3000 location is b8, but what we want to add actually are bf and cd, right? So just type in bf. Now we entered successfully bf at memory location 3000. Just type now enter space. Now this is memory location 3001. So already 06 is present, but we don't want that, right? We want to add cd, right? bf and cd. So just type in cd. and enter. Now we gave our inputs BF and CD. Now we should again run the program once after giving the inputs, right? So just type in G same equal to 4 zeros successfully, and we have already gave the inputs. Now we want to see the result, whether our program is correct or wrong. So to do that, just type in space D and 3002 comma 3003. What are these 3002 and 3003 actually? So I said before, right? Remember these these memory locations are important. So this is because this is what the reason I said they are important. So first we have moved our AL to memory location 3000, right? And BL to memory location 3001. These are our inputs. The result is stored at what locations? 3002 and 3003, right? These are the starting and ending addresses of our output. So we have to type here is minus D and starting address of our output comma ending address of our output. And the starting and ending addresses in our case are 3002 and 3003, and just type in enter. Now we are getting the answer as 8C00, that is 00 and 8C. So but let's verify our answer by looking into calculator. The answer we should get is 018C, right? But we are getting 008C. See, you can verify from here as well. From AX register is containing 008C, but we should get 018C, right? So what is the error in our program? I mean, there are no errors actually. So we will just quit from our program and we will edit our program. So to edit back, just type in edit and 8bi t.asm. So what is the error actually? So if carry occurs, what we are doing over here? Yeah, this is what the error actually. See, if carry occurs, we are saying that jump to memory location L1. What we are doing in location L1, we are just incrementing SI, but we are not incrementing AH. That is, if a carry occurs, carry is 01, right? So we should increment AH by 1. Why? We are storing carry in our AH, right? What is the carry will be 01. So in order to make AH from 000H to 0001H, we have to increment AH, right? So that we can get the carry. So this is what the error I think so, and our program should work finally. So just click on the file, same again, and click on this save. Again exit. Now same commands, just type in masm 8bit.asm and 4 times enter, and again link, again 4 times enter, again debug. Now to run the program, minus G equal to 0000. Now we have to give inputs, right? So type in minus E. From where we have to give inputs? We want to give inputs starting from 3000 location, right? So just enter, and the inputs we want to give are BF space CD, that is BF at 3000 location and CD at 3001 location. Just type in enter. Again we want to run the program right after giving the inputs. So just type in again G equal to 0000, enter. See, now you can get result from here itself. So you can see the content of AX over here is 018C. So that is what we got right in our calculator, 18C, that is 018C. We can verify in this way as well. So type space D, and what are the starting address of our output is 3002 comma 3003, right? So just enter. Yeah, we got the answer. Finally we got the answer, that is 018C. Higher bit is 01 and the lower bit is 8C. So we successfully added two numbers, and that's it for this video. And don't forget, see, if you want to do subtraction, just replace that add by sub subtraction. That's it. Don't worry, we will see it in the next video. And in the next video we will see how to add two 16-bit hexadecimal numbers, and as well as I will also show subtraction as well. So if you like the video, give it a thumbs up. Thanks for watching.